This video we will be continuing on the beginner's guide to SDL2 in the Go language. So if you're just starting with this video, you'll need to go to github.com programming rainbow beginner's guide to SDL2 in Go. You'll need to clone that repository, move inside the directory, and since this is the fifth video, we will be working with the source code that we finished off in the fourth video. So you can go ahead and grab the source code from video 4 folder, copy that main.go into the top level, and that is what we will be working with today. So in this video, we are going to be dealing with TrueType font. We're going to make TrueType font. We're going to start up the TTF module and quit it. We will open a font and also close it. We will use that font to create text onto a surface and then be able to free that surface. We will also convert that surface to a texture. We will get a rectangle from that. And then we will try, if we have enough time, to move it around the screen. So that's everything we're going to be doing in this one. So I'm just going to show where we left off in the last video. Let me make this bigger. So we have this window. It's 800 by 600. It has an image being drawn as the background. We can change the color behind the background image. It has a title up there. It also has an icon that's been loaded, but I'm not going to show it to you. I showed it in the last video. And we can close it with the escape or the whatever way that you normally close a window. Okay, so like I said, in this video, we will be working with a new module called the TTF module, TrueType Font module. So that is one of the packages. Sorry, not module, but package. So the Go SDL2 module has several different packages inside of it. We've worked with the SDL package, the base one. We've worked with the image, and this video we're going to be working with TTF. So if we go into the TTF, that's not it. This one right here. You can click on it. I just already have it open. So if we go into here, we have all this kind of stuff we can do with TTF, but the first thing we need to do is initialize it and quit it. And that's already opened over here. And the nice thing about initializing TTF is there is no flags to pass in. So we're just checking the error on it when we initialize it. And then to quit it, we don't need to pass anything, arguments into it. We don't need to check anything coming out. So let's start with that. So this is going to be simple. It's just going to be like the way that we initialize the other modules. And we do need to add TTF in here to this list. So I'm just going to grab this SDL one right here. I'm just going to yank that and then add it down here and change the SDL to TTF. Okay, so now that that's there, I'm going to go down to Initialize SDL, and I'm just going to grab one of these because it's going to look exactly like this. I'm just going to yank this one right here. And we have no flags going into this, so I'm going to remove the flags. And also, this is not image in it, this is TTF in it. And for the error message, we'll say error initializing SDL TTF. Or, sorry, yeah, TTF, yeah, there we go. So that is how we are going to bring the TTF module online. And the way we bring it offline is we're going to put it on top again, so it's the last thing that we loaded. It'll be ttf.quit. That's our method that we're calling there. So I'm just going to compile this real quick because I've added a new package in and I've brought it online and bringing it offline. So I just want to make sure that that is working correctly. And it still looks like it's fine. So the next step that we have to do, we've brought the TTF package online. In C, it's a module. I'm going to use either term, but I know the correct Go term for it is the package that's inside the Go SDL2 module. So I'm just going to close these that we've already used, the init and the quit. Now we need to, before we start making text that's an image that we can use, we need to just create a font first. This is just a font object that we're going to use to create text. So the font, we're going to use open font, and this is going to take the string to the actual TTF font that we're going to load. and it's going to take a size that we're going to use. And then it's going to return a font object. This is heap allocated, so we do need to manage this. And we have the error. So this looks very much like when we were doing other types of things. We basically have the object and we have the error. And we're just putting in the string and the size. Okay, so let's do that. But what I'm going to do is I'm going to first show the true type font that we're going to load. It's in fonts and it's free sans bold. So this is what we're loading. And also for the size, I'm going to put 80. So up here in game, we're going to need to add a couple things. We know that we're creating a font, and what we're returning back is it's TTF. It's this font object, which is going to be in the TTF package. So it's a pointer to a font. And we know that we need a font size. So right here in the game struct, just looking at where I want to put this, I'm going to put it right after, so it looks like my notes. But I'm going to say I want a font size, and this will be an int. And then I also want the actual font. So I'm just going to call that font. We could save it in the class, but or in the game struct, but we're only using it one time. So we could load it and then unload the font right away. Yeah, that's what we're going to do. Okay, so I'm just going to put this here. This. Now I'm going to populate this, and what I want is this is the size that the font. I'm not sure if it talks about it here. It says font loads file for use as font at the specified size. Now this is a point size. This is not a pixel size, but I'm going to use 80. And you can play around with it and try different sizes. And if you want to read more about it, you can open up. I'm not sure if this is the wrong link, but you can just Google SDL2 and open font, or TTF open font, and you'll find the correct page for it. I can just try it real quick. This might be, yeah, it's a broken link. So if I just Google SDL2 and TTF open font, I'm going to get the correct current page, which is right here. And I believe this is a point size. Yeah, it says point size. So this is the actual C SDL2 reference. This one here is the Go implementation. Okay, so we're going to make it 80, size 80. So down here in the new game, I'm going to create this as, or I'm going to set it to 80. Okay. And so I could have saved the font here in the game struct, but since I'm only using it one time, just like we did in the last video where I was only using down here, I was only using the icon surface one time. Instead of holding on to it, I just created a local variable and then I deferred the freeing of it immediately. So I'm going to do the same thing with the font, but it's not going to be here in it. It's going to be in the load media. So I'm going to make it, like I said, a local. And it's just going to be, yeah, I'll just call it font. Font, and we also need to capture the error. I'm going to let Go populate the type for me. And this is TTF open font. Now it's going to take the relative path to where this font is. So this is being called from the top level directory. So it's going to be fonts, free sans bold TTF. Okay, and then we also need the size of this font, which we have saved in the font size variable. And then we're going to check if the error occurred. Oh, okay, so I know what I'm doing. I can't put it in an if statement like I did just like how I did with up here. I couldn't wrap this in an if statement because I'm actually declaring this variable right here. So I'm just going to do this exact same thing right here. I'm just going to yank this because I want to check to make sure an error hasn't occurred. And we'll call this one, we'll say opening font, because that's what this method is doing. Okay, so opening font. And I'm going to defer the way that we close a font is we can call a method on font that's closed. So here we have open font. This is a function, but to close it, in C it would be a function as well, but in Go, they've attached this as a method to the actual font object. So I'm going to close this window, and the very next one over here is, see, this is a method of font, and it's just close. And this is going to close the font. So I'm going to defer that. So this gives us a font. So now what we really want to do is generate some text onto a surface or a texture. We can't go straight to a texture, but we can generate text with this font and a string. We can generate a surface with it. So that is what we're going to do. And that function is called, in C, it would be something like render text blended. But in Go, it's actually render UTF-8 blended. So, yeah, it's right here. Render UTF-8 blended. So UTF-8 is just a normal string. You know, it's a UTF-8 encoded, which is just the normal one. So, so this is returning a surface and an error. So we've seen this all before. We got a surface and an error coming back out of this. This is just kind of like if we were using image load, we also returned a surface and an error. This one, this is a method of font. So we're going to be using our font object. We're going to call this method on it. We're going to pass in the string that we want. We're going to pass in a color, which I completely forgot about, but that's fine. And we're going to get our surface back in our color. So since we need this color, let's just open that up real quick. Well, I know what it looks like, but I would like to show it better than what I have to show here. Well, let's open up this. This is the C version. What it is it's just a struct that has 4 uint8s. That's 0 to 255. And we did something similar to this when we were changing the background color, but this is just a struct that holds it all together. That actually holds the color. So we have RGB and alpha. And so when we can create a color and we can just set the R, the G, the B, and the alpha to the color we want. And I'm just going to make white text, but you can choose whatever color you want. So this is what it is under the hood. It doesn't really explain it very well here, unfortunately. I mean, okay, here we go. This is what we're doing here. So the color is going to have RGBA, and they're all uint8s. So we'll just create that. I'm going to create it up here in the struct. I'm just going to hold it in the struct, and I'll just call it font color. Whoops, capital C. Font color, and this will be of type SDL color. Okay, and then down here in the new game, I'm going to initialize it. This will be G font color, and this will equal, and I'm going to say SDL. Looking at the wrong thing. It's going to be SDL color and curly braces, and then I'm going to say R colon, and I want white. So your range that you get to choose from is 0 to 255, and these work. The RGB are basically, when you add all the colors together, you get white, and in the absence of all the colors, you get black. So it's not like the cyan, the other one with the yellow in it, where if you add them all together, you get black, and if you have none of them, you get white. This is the opposite. So if you have 255s across the board, you're going to have a white color. If you have zeros, with the alpha still set at 255, you're going to have black. So you can choose whatever color you want based on that. You can go from 0 to 255. For white, I'm just going to do 255 on each of them. And the alpha. Okay, so no matter what color you choose, you're going to want this alpha to be set to 255 because this makes it opaque. If you use anything lower than this, it's going to start to be transparent. And if you get all the way down to 0, you just won't see it at all. So you're probably going to want to see the text that you're creating. So, and I don't mean the background is transparent. I mean the actual text that you're going to see will be, you won't see it, or maybe you'll partially see it depending on what number. So you're going to want this to be 255. But these ones, you can use any kind of combination of red, green, and blue that makes whatever color you're happy with. I'm just using white for this one. So we have our font size, our font color, and I'm just going to put the text in line with it. So back down here in load, where we have the load media, right here is where we're going to use the function. Let's look at it one last time. The render TTF blended. This is going to take the font. This is a method on font, and it's going to take our string. It's going to take our string and our color, and it's going to give us back a surface that has whatever string on it in that color and or the error. Okay, so this is called render UTF-8 blended, and the blended means it's going to have a nice looking curves around the edges. It's not going to have kind of aliasing, pixelated. It's going to make it look nicer. Okay, so we have this font. We'll go font. I'm just going to paste this here. And we are receiving back from the font surface. And this is a local variable again. So I'm not creating this in game because this is going to be temporary. Serve. And we got the font surface and we got the error. And what we need to put in here is a string. And I'm just going to put SDL. And then we have our color. So this will be G font color. And since I'm doing it this way, I can't wrap this in an if statement. So I'm going to put the if down here and do the exact same thing I was doing here. And we'll say, oops, our error message will say creating text surface. Okay, so we're checking that error. So hopefully we have this local, we have a local font, but we're deferring the close on that. We have a local surface, and we already have seen how to free a surface, which is just calling free on it. So we'll defer that. So that should free our surface. But what we really want is we want a texture. And also we want a rectangle, because if we don't use a rectangle, I'm going to show it first without the rectangle. And you'll see it's not going to look nice. And then we will do the rectangle and you'll see it better. So I'm going to skip the rectangle for the time being. But what we need to do is we want to convert this surface to a texture. And this is a method on the renderer. Okay, so it's a normal SDL thing. It might be open over here. That's about the surface. So the surface actually has a width and a height information. We'll come back to that later when we get to the rectangle part. And that's the rectangle. We'll come back to that later. So right now, to basically take a surface and turn it into our hardware accelerated texture that uses the render, it's actually a method on the renderer. So we already have a renderer. So we're going to call this method create texture from surface. And it's going to need the surface that we want to create a texture from, and it's going to return a texture and an error. I'm just going to copy this long method name. Okay, so again, this is a method on render. So I need G render, and that's the method. And it's going to take in our surface. I think it's just the surface, right? Yeah, it's just taking in the surface. So that is font, surf, and it's returning the texture that we want, and we haven't we haven't set this texture up to store it yet, so we're going to need to do that, and an error. So I'm going to say G, we'll call this text image. So text, and I know we haven't created this yet. And we're getting text image and error. And I'm not declaring this here, so I'm not using a colon. I'm going to go up here and I'm going to declare it in the struct here. So I'm going to put it right below the background image. And this is of type SDL-Texture, just like we've done before. We've already seen how to deal with the texture before. Okay, so that is there now. Now, if we go down here into load media, we'll be able to grab that out just fine. So we can wrap this one in an if statement because we're not declaring anything here. So I can put an if on this. And then back here, I can put the error is not equal to nil, like that. And then we can just take one of these messages, yank it, put it right there. And we'll say, creating texture from surface. Okay, so this is going to give us our final texture. Finally, after all these steps, we've created this font and we've deferred closing it. We've created this surface that has text on it, but it's not accelerated, so we don't really want to use it. We've deferred closing that. And now we've taken this surface and we have created an actual accelerated texture from it. And that's the one that we actually wanted. So these other two are going to go out of scope at the end of this method call, and they're going to be cleaned up by their defers. This last one we're holding on to. So here's our final texture. We actually should have SDL now, and I didn't set up a rectangle yet. So let's see what this looks like. Okay, so we have this. I just want to run it. Well, let's put it in here. So it's going to look just like this. So we already have a background texture. We're going to do the exact same thing. So I'm just gonna take this line right here and I'm going to yank it. And remember, I said that we would use a rectangle this time, but I'm just going to show you what it looks like if we don't use the rectangle. So we're going to use our entire source and our entire destination, and we need this image to be our text image. Okay, so our text image, and now the TrueType font makes font that is nice and smooth, and it doesn't have any kind of jagged edges and stuff, and that's really nice. The problem is we've made a size 80 font and then turned that into a texture, and then we've stretched the texture, so it's actually going to look really ugly, and that's not the fault of the TrueType font. That's me stretching the image. So I'll show you what that looks like. Okay. So this ugly pixelated font is not the fault of the TrueType font. It should only actually be this big over here in the corner. And I've created a texture from it and then stretched it. So what we really want to do is display it correctly with a rectangle. Okay, so all a rectangle is, the underline, let's see, where's the rectangle? Oh, here's the rect. So all the rect is a struct that has 4 values in it, which are int 32s, 32-bit signed integers, and they have an x, a y, which is going to be where it's placed, where the origin or the top left-hand corner of it is, where that top left-hand corner of the rectangle is, and then a width and a height, how wide it is and how tall it is, from the top left basically going to the bottom right. So that's a quite simple thing. What we really need to do is to populate the width and the height, and where we can get that information 2 different ways. We could query the texture that we have and get the width and the height out of the texture, or we could actually pull the width and height directly out of the surface that we had. So since we already had the surface in this one and we converted it to texture, I'm going to show you how to pull it out of the surface. And then when we load an image later, we'll do the texture version. We'll do the querying of the texture. So we have this surface already that we have already created, and it has a width and a height that are 32-bit ints. Okay, and that's width of our surface and height of our surface. So we could just grab these straight out of here, out of the surface, and set them into our rectangle directly. Okay, so we're going to do that. So I'm gonna add a rectangle up here into the game struct. We'll just call it text rect. And this is of type SDL rect. And it's not a pointer to a rect, it's just the actual rect. Okay, I know most of them are pointers. The color is also not a pointer. The rect is not a pointer, but this isn't heap allocated. This is just a struct with 4 numbers in it. These other things are actually heap allocated. The color, again, is just a struct with 4 uint 8s. This is a struct with 4 32-bit ints. So we don't have to clean them up. They're just on the stat. Well, this game struct is actually on the heap, so they're inside of this on the heap. But that's Go managed. That's managed by Go. Okay, so down where we're doing our load media. So after we get our surface, so we've got our font, and now we have got the surface. So right down here, after the defer, I can just set my width and the height of my text rect to the width and the height of the surface. So we can just go G text rect, and it's a member, and in C it would be a lowercase, but in Go they use capital for these. But so it's a text rect width, capital W, and I was just set that equal to the font surf dot W. Okay, so that's font surface right here. It has a width, so I'm just doing that, and I'll just yank this. And I'll do the height as well. Okay, so we have those two set up. So now that we have this rectangle that has a width and the height, we don't actually need to set the X and the Y. They're going to be, since it's Go, they're already pre-initialized to 0. So if 0 is the top left of the image, but it's our destination, 0 is going to be the top left of the actual window that we're doing. So this will draw the text in the very top left if we use this rectangle. So when we go down here, we can use the rectangle here, text rect, right? This isn't going to work. Oh, it actually did it for me. I was about to say this isn't going to work. We need the address of it, but it's already auto-completed correctly for me. So you just put the text rect, but you do need the address. We don't copy in the rect. We actually pass the reference in. So now when we display this, it should look like nice text, and it'll be in the top left-hand corner of the screen because we didn't change the X and the Y. So we're still getting the entire source, which is our actual text image. But how we want it displayed on the render is actually only going to be the width and the height that it should be displayed onto the render, and in the 0, 0 location for X and Y. Okay, and it looks nice here. So I'm going to change the size of this to 320 just to show you what it looks like when the text is larger, that it doesn't look pixelated. So I'm going to go to right here, and I'm just make it 4 times larger. That's what 320 is. Okay, and you see it's still nice looking text. So it was only because the texture that I created before I stretched. Okay, so this texture, we did not set up the cleaning up of this texture. So we have this new texture. We need to add it here to the close method of game. So it's going to be exactly like this right here. Remember the other ones, the font and the surface have a deferred, they're local. They're created locally and they have a deferred close on them already, but not the text, the texture, the text image. It is not, it's a texture. So text image and this one as well. So that is taking care of that. And we are shutting down, we are closing the font already, and we are shutting down the TTF. Yes, that's all good. Okay, so what we really want to do is we want this thing to move around the screen. We want the text to move. You know, we could manually change the X and Y, but what I actually want to do is to let it move around the screen. So what I'm going to do is I'm going to create some variables for velocity. So what I'm going to do here is I'm going to create a couple new variables under rect. And these are just going to be in32s. The reason why they're in32s is because that's what the rectangle X and Y accepts as the type. So I'm going to call this text velocity, and this is going to be my this is just going to be my velocity that's always there, and I'm not going to use that. I'm going to write it the go way. There we go. Velocity, and this is going to be an int32. And then I'm going to have a text x velocity and a text y velocity. Okay. So what I'm going to be doing is I'm going to be changing this x and y, and I'm going to be setting it to either the positive or the negative variant of velocity. So velocity is just the actual speed. X may be a positive or negative version of that, and so is y. So down here in the, right here in init, the init method, I'm going to be setting them, and I don't want it to move too fast. I'm going to set it to 3, and assuming that this is happening at 60 times a second, 3 times 60 is going to be 180 pixels per second that it's moving at. However, it's going to be moving diagonally, so it's going to appear to be faster than that. It'll probably be closer to like 250 or something like that, because that's 180 on the X and 180 on the Y. So I'm going to set this one to 3, and then I will set the other two to it. Okay, so that will set the velocities. And then what I'm going to do is I'm going to create another method on my for my game. And this one's going to be called update text. So this is going to update the text and let it move around the screen. I'm going to put this underneath the random color right here. So this is a game method. And we'll call it update text. And what I want to do first is just move using the X member of the text rect by the text X velocity. And I'm going to increment it by that. Okay, so we're just going to do that and see what that does real quick. And I do need to call it. So this is something that's updated in the state. So let's go down into our game loop. And this is what's happening in the game loop. First, I want to check for events. And then after I check events, I want to update my game state. And then after I update my game state, I want to draw my game. Okay, so right here between these two, I'm going to add in the G update text. Okay, so that's going to call that, and so each frame that is going to be called, and it's going to update the X position by the X velocity. So we should see the text moving across the screen from the left, top left, to the right, and then off the screen. There it goes, and it's just going to keep going straight off the screen. Okay, so now we want to deal with, can we make it bounce off the other side? Where is that? It's right here. So this is just pretty easy. I'm just going to put an if else, if and an if else. So first I'm going to check if imagine if I'm moving to the left, I just want to check the X. Since X is already the left side of the image, the texture, I want to see if that X has actually broken the 0. When it hits 0, it's starting to go off the screen. So I can say if textRect.x is less than 0, right? So if it is less than 0, I already know I was moving to the left, and I want to make the text start moving to the right. So the only thing I need to do is change that velocity. So X velocity equals, and I want it to be the positive version, so I'm going to see G velocity. Okay, so this is positive 3, I already know. So to be moving left, it had to be negative number. So I'm just setting it now to a positive number. And that is if I was moving left. So what if I'm moving right? I'm going to do an else if. I'm going to put this in, I need to add them together. So what I'm going to do is to get the right-hand side of where the text is, I need to take the X, which is the left-hand side, and add the W, which is the width. And that will give me the right-hand side. So I want to check the right-hand side against the actual width of the screen, which we have as a constant up here. Right here, window width. So I want to check that. I want to check X plus width if it's bigger than the window width. Where did I put it? Am I right down here? Yeah. So this is what I'm going to do here. I'm going to put it in parentheses. I'm not entirely sure if it needs to be, but it's just easier to read. Dot X plus G text rect dot width. So if that is bigger than the window width, if it is bigger than window width, I need to move it in the negative direction because I've gone too far and I'm going off the right side. So I'm going to set the G text X velocity equals negative G text velocity. Right here, this is a G. Okay, so let's see. It should now move left and move right and keep bouncing off the sides. Okay, there we go. And the other side. Okay, that's perfect. What about up and down? Well, if I take this exact same thing, I'll take this right here. And I'll just change the X to the Y and this one to the Y as well. And then if I just take this, it's going to be the exact same. I just need to change the X to Y's and the width to height. Is it? And right here is the Y. And that's Y. And this is height. So it's H. This is height. And this is going to be Y. Okay, so that should give us bouncing all around the screen. It looks like we're bouncing off all the walls just fine. We don't have any issues. It's a very, very simple thing. Whenever it has gone too far one direction, I'm just changing the other direction. I'm not trying to multiply it by -1 or any fancy business like that. I'm just telling it, nope, you need to move the other way. It's a very simple setup. Let's change the title up here. We can call this creating and moving text. creating and moving text. And we'll just walk through the steps that we've done here. So we've initialized we've added in, the TTF package right here. That's part of the Go SDL2 module. And we have initialized it here. There is no flags for the TTF in it. So it's just in it checking the if statement to see if it errored. And then we are quitting TTF right there. So with this TTF package, we need to load a font. We are setting up some variables here. We have a font size int. We have a font color, a text rect, and then we have those velocities that we set up. We are initializing the font size to 80 and the color. We are initializing or setting it to SDL color with all 255, so we end up with a white opaque color. And then we are setting the velocity to 3, and the X velocity and the Y velocity is just set to the velocity. We're just using those as toggles to change direction. So in game minute, there is nothing new happening. In load media, we are first creating a local font. So we're loading the fonts free sans bold and using the font size. So we're loading that, checking to make sure that an error didn't happen, and we are deferring the close of this font because this font is heap allocated. And this is just local, so this font is going to go out of scope, and then this font close is going to be called. Now that we have the font, we can call a method on this font, render UTF-8 blended, and that gives us the blended version, gives us a nice looking font. And this is a method call that is taking in a string and a font color that we've set above, and we are returning a heap allocated font surface. Okay? And checking the error on that, and we are deferring the freeing of this font surface. That is how we get rid of the surface. We use free on it. So those are being deferred. Since we have this surface already, we're taking the width and the height out of this surface and storing it in our width and the height of our rect. Now that we have the surface, we really want a texture, so we're using a standard method of render, which is part of the SDL2 package. And we are using the create texture from surface. We need to pass in the surface. We're seeing if an error occurred. This is heap allocated, so this texture, this is being stored in the game struct, so we are managing that later. And we have our error message here. So with that being managed, let's go down and we do destroy that texture here and set that pointer to nil. The other two managed things are deferred and they're going out of scope here, so they're being taken care of that way. So now that we have this texture, we are drawing it down here in our render, just like we did with the background, but we are using a rectangle this time, and you do need to make sure that you're passing the address of this rectangle to this method call. Okay, so and then what we're doing is we're actually calling this update text method that we created of a game method right here. And what that's doing is that is just incrementing the x by the x velocity and incrementing y by y velocity. And then we're checking bounds. And if we've gone off the left-hand side of the screen, we're making sure that our x velocity is the positive version of text velocity. But if we go off the other side, we're checking the x and the width to get the right-hand side of it, checking that against the global constant that is our window width. If that did in fact go off the right-hand side, we are setting our text x velocity to the negative version of text velocity. And then we're doing this exact same thing for the y's. Everything is just switched to y, h, and height. And that's going to handle the y direction. That allows it to just bounce around the screen, and it's moving at, again, 300 pixels per second on the x velocity and on the x-axis and the y-axis. And there is nothing new here except for the update here and the render, and nothing new in here. Okay, so that is how you create TrueType font. If you're using it for title screens or for scores or information on the screen, that's what you would use. And if you wanted to move it around, that's how you would do it, and converting to a surface and all that stuff. So there's a lot of useful information there. I hope that was entertaining or educational and you learned something. So again, thanks for watching, and bye.